All right. So this is the tutorial, and the speakers are going to be me, Sina, Lucas, and Bali, which I forgot to add here. All right. So let's dive right in. So first, I want to motivate a little bit why it's advantages to use dynamical systems for controlling robots. So one of the main advantages is that dynamical systems have this really nice property of being robust to perturbation. So for example, here we can see that the dynamical system basically has a target here on the cup, and here the target is on this green block, and the execution of this motion is robust to perturbations by the human or from the environment itself. Also another, oh yes, it's not working. Yeah.
Oh, no, this.
What? Yeah. Also another nice property is that with dynamical system we have really fast adaptations to, for example, a changing target. So and we have this ability to like instantaneously replan our motion. So here we can see two examples where we're using dynamical systems in a really fast application where we want to catch a flying object. So these two properties, fast adaptation, reactivity, and robustness to perturbation, are also, we also can exploit them to provide physical human-robot interaction through compliance, being compliant and being passive to perturbations from the human, and being able to adapt to what the human wants to do and how it wants to modify the task. So, okay, so I'll begin from scratch what is a dynamical system. So it's basically an ODE, an ordinary differential equation, which defines the evolution of a state variable x. So there's two types of the dynamical system. So first one is a non-autonomous DS, which is driven by a time-dependent ODE of this form. This is a really popular approach in control, but it sometimes is problematic due to if we have like some system delays, for example. Then there's the autonomous dynamical systems, which are driven by time invariant ordinary differential equation. And this is really good because it lacks this explicit time dependency. So it makes it really robust to perturbations, which is the videos that I showed at the beginning. So dynamical systems are really useful in many areas of science and engineering. For example, physics or mechanical engineering, in computer vision, and in robot control, which is what we're going to focus on today. So we have some biological evidence that dynamical systems drive some of the underlying motion of vertebrates. For example, for a reaching task, here there's a study that showed that monkeys use, for example, a fixed point attractor dynamical system, and also for locomotion, we know that the underlying, let's say, controller is a cyclic pattern, which is driven by a central pattern generator, which is also a dynamical system. So in this tutorial, we will focus specifically on autonomous dynamical systems, how to learn them from demonstration, modulation strategies of dynamical systems. So given a nominal dynamical system or a dynamical system that you learn from demonstration, how to modulate it, and how to use it for impedance or force control. So those are the three main lectures that we're going to give today. Alright, so basically this is the outline. The first lecture will focus on learning strategies for autonomous dynamical systems with an exercise session in MATLAB. Then we'll have a short break. Then we will introduce to you some modulation strategies for like locally reshaping an existing dynamical system, for obstacle avoidance, and for making and breaking contact with surfaces. Also with an exercise session in MATLAB. Then we have another break. Then we go to the third lecture. There was a noise. Okay. Then we go to the third lecture, and which focuses on impedance and how we use dynamical system for impedance and force control. All right. So this is a website for the tutorial. Here you will find right now all of the slides, all of the links to the exercises, which are in our GitHub page. So you can go to these to either of these links, and you can either see the website or download the exercises already, so you can start playing around with it. So now we go to the next